Okay, ran out of time there, so let's just finish this up. So, what is the domain of tangent? Well, the domain are basically everything except any asymptote. So when we have an infinite number of these, when I said show and label all 6 asymptotes, we're going to concentrate on those asymptotes. So x cannot equal, we'll start over here, well, we'll start with negative pi over 2, pi over 2, and we'll just keep working outwards. 3 pi over 2, I could go plus or minus just to make things a little easier. And then this is actually 5 pi over 2 and negative 5 pi over 2. And hold on one second. And this book wants you to consider all of them. So again, this goes on for an infinite number of time, that way and that way. So if you notice, odd number, there's an odd number, there's an odd number. So I could actually take this right here, domain, and I could go plus or minus pi over 2 times n, but n must be an odd number. And this would show all the things that x can't be. Range is a lot easier. On all of these, how low do they go? Negative infinity. How high do they go? Infinity. So that's all real numbers. X-intercepts, again, there's an infinite number of them, but if you notice, it starts at 0. So we got 0, 0, but we've also got negative pi, positive pi. So we got plus or minus pi, but also, that would also include 2, 3, 5. So that'd be n times plus or minus pi, and that's any number or whole number. 1, 2, 3, 4, 5, 6, 7. And that's plus or minus, really, because it can go both directions. And I should add 0, and that would technically take care of it, just like that. Okay, and then out of nowhere, we got to solve a system. We don't like these decimals, so let's hammer them with a 10. So we get 5x minus 2y equals 30. I'm going to bring this along for the ride. X plus 4y equals 5. Now I'm going to go ahead and multiply this one by negative 5. So I get negative 5x minus 20y equals negative 25. Now I'm going to add these together. X's will cancel, so I get negative 22y equals 5. Notice these numbers are not turning out nice, and you're going to have to get used to that. So negative 5 over 22 equals y. I'm going to plug this in here because that's the easier one to go for. So x plus 4 times negative 5 all over 22 equals 5. So, running out of space, x minus 20 over 22, I could reduce that, equals 5. I'll just do it over here. So x minus 10 elevenths equals 5. Now I'm going to make this 55 over 11 because I can see what's coming. I'm going to add 10 elevenths to both sides. So that cancels. So my answer would be, my x is 65 elevenths, comma, negative 5, 22. All right, simplify. Well, we're going to break this down. Square root of 16, square root of 2. There's a 4 there. So that's 4 times 4, which is 16 square root of 2. Do the same thing here. Square root of 9, square root of 2. That's 3 times 5 is 15. Minus 15 square root of 2. So we'd end up getting 1 square root of 2, which you could just write either way. Okay. All right, just throwing a little curveball at you on number 14. Is the graph from number 10, that's our circle, even? Well, let's do the test. An even function, if we flip it over the y-axis, you would just regenerate itself. And we're like, yep. Odd, if we rotate it 180 degrees about the origin, we would regenerate the graph. Yes. It's not neither. It's both. So it passes both of those tests. Okay, fancy talk is we're composing functions and we're going to sketch the resulting graph. Transformations fit into this language too. So first of all, here's our parent function. It's the absolute value function, which we recall looks like this. And now we're going to have to put this in for x, so we end up getting x minus 1, but that's also 2. So what happens? Well, two things happen. Number one, we got to move the function to the right 1, and then we've got to vertically stretch the parent function. So it would look something like, and again, I'm going to get in the ballpark, but instead of going up 1, right 1, up 1, right 1, it's going to go up 2, right 1, up 2, right 1, and we kind of get the idea there and try to duplicate it. And so there we go. All right, number 16, we're moving along. So it says, assuming the points given are negative 3, 0, so that right there is negative 3, 0, negative 2.4, negative 20 is this guy right down here. So negative 2.4, negative 20, and 0, 0 is right here, pretty obvious. It says, where's the graph increasing? So this goes back to our roller coaster ride. So we would say it's increasing from here all the way to here, because we've got to move left to right. So that would be x is greater than or equal to negative 2.4, less than or equal to 0. Remember, we're talking about the x value because it's left to right, and that's always our x-axis. Where is it decreasing? Well, there's a couple of chunks. So the first chunk I can see from here all the way to here, I'd be going down, and from here all the way there, and just assume there's arrows there. So we would say x-wise, x greater than, or, well, it's just strictly greater than negative infinity, because that's where it's coming from, this way, negative infinity, all the way to negative 2.4. Some teachers disagree with the or equals. I include it because it stops there. It definitely touches that spot. That's where it ends, but some teachers just put less than. I'm not going to get too worried about it. But it also is decreasing from 0 all the way, well, infinity is a different story. It's not, you can't get there mathematically, so they say just less than. So a little technical. Where's the relative maximum? It's right here, 0, 0. That's the peak. Where's the relative minimum? That would be here. So I'll just draw an arrow and call her good. Home stretch. What is sine of negative 5 pi over 3? Remember, pi over 3 is 60, so that's negative 300. That means we've got to spin our spinner this way. There's 270 plus 30. You should be perfectionistic about it. So that's 30, meaning this is 60. Drop that down. We know our square root of 3 is opposite our 60. It doesn't say anything about a unit circle, so we're going to use our regular dimensions for a 30, 60, 90. So what is sine? Opposite over hypotenuse, square root of 3 over 2. Solve for x. Well, we're going to have to subtract 10b from both sides. So we get 5x squared equals 10 minus 10b. Divide by 5. I'm going to divide this all by 5. X squared equals 2 minus 2b. Bada boom, bada bing, do the right thing. So we get x is plus or minus the square root of 2 minus 2b. Factor. Well, this is a gotta one. To find two factors of negative 10 that add up to 6. Well, that would be plus 10 and minus 4. Here's our not a 1. So if we're going to use the rainbow technique, you could just use trial and error, but let's use the rainbow technique here. 6 and 4. Rewrite it so that we can factor by grouping. So then we insert our parentheses, take out a 3x, we're left with x plus 2. Take out a 4, x plus 2. Notice we got a match, which is good. X plus 2, 3x plus 4. All right, just getting a little jump start on number 20. It says if tangent is 5, 6, and I forgot to put in quadrant 1, so that helps us know where we can get started, because tangent could be 5, 6 over here too, because we'd have a negative over a negative. But in quadrant 1, says what would tangent be if you went 180 degrees farther than this spin? Well, that would just take you into the third quadrant, and now this 5 would be negative 5, this 6 would be negative 6, and if this was our reference angle, we'd say, hey, opposite over adjacent, we would still get 5, 6. Now this could be like pi over 2, and that would take that, and you would have to go, redraw it 90 degrees and then recreate it. But that 180 made it a lot easier. Okay, using cosine of theta, sine of theta, what point corresponds to a negative 312 degree spin? Well, we're not going to be perfect about this, but 270 is right here. And then if we went, what would that be? 42 more, it'd be right in there somewhere. So it's really asking for where's that point? Well, if we just stick that in here, let me pause this. All right, I went ahead and did some math. So I took that theta, put it here and here. You can see it sitting right here. Got my calculator out and just typed it in. I got 0.67, 0.74, which means this would be 0.67, 0.74. And if you wanted to double check it, you could go a squared plus b squared equals c squared, and you're going to get something really close to 1 because we round it a little bit. And this is giving you the coordinate in a unit circle. 22. If g of x is this, and f of x is this, saying plug f of x, this stuff, into g, wherever x shows up. We're like, okay, and here comes a PEMDAS special, so it's 4 times 2x squared minus 1 squared plus 2. You can't just square that and think you're doing a good job, because that's not true. We actually have to FOIL this out. 2x squared plus 1, 2x squared plus 1. That's 4x to the 4th. I'm going to go outside and inside together. 4x squared plus 1. That's all this. Still got to multiply that by 4. So we get 16x to the 4th plus 16x squared plus 4, and then plus that 2. So we're going to add like terms, and I'll put my answer up here. 16x to the 4th plus 16x squared plus 6. All right, grand finale. We're going to get it done. Fifth root. Well, if you think about it, 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5. That's 4 times 2 is 8. 8 times 2 is 16. Times 2 is 32. A 2 pops out. So then all we got to do is concentrate on this. Well, what's the first number less than 11 that 5 goes into evenly? That's 10. So we take 10 of them away. We're left with 1. Remember, there's a 5 in there. Don't forget the index. So how do we figure this out? Remember, you take the power, put it over the index, and so we end up getting 2x squared times the 5th root of x. Don't forget to put that in there, else it's technically wrong. And that does it, you guys. Come and ask me questions if you have some. Have a great day, and good luck.